All right, hello everyone. Going to finish up the notes here from this morning. Okay. First, we talked about we are factoring quadratics today. Oops, let me go on the full screen. Okay. Wonderful. But game technology clearly are not getting along right now. There we go. All right. So we talked about this first page of notes here, where of course you guys are able to read through here, um, learn we're factoring quadratics again. We said that was the opposite of FOILing. We're undoing a FOILing problem. So this morning the example I think was like x plus 2 times x plus 3. If we were able to FOIL that, we do the x times the x, get x squared plus 3x plus 2x plus 6. And so we end up with like x squared plus 5x plus 6. Okay. So yesterday we were kind of undoing the distributive property. Well, today we're going to be undoing FOILing. And we'll use this method here that's described on the first page to do that. And again, we talked about this morning. So you guys welcome to again read through that, but we'll continue. And then we even got into the listing all factors. Okay, this was a skill that we needed to be able to do, was to list factors of numbers. And we talked about, always you had 1 times the number itself, 1 times 6. Those are factors of 6. The other factors of 6 that we talked about, 2 times 3. All right. And these are the only numbers. These are the only 4 positive numbers that multiply to 6. And so these are the 4 factors of 6. 1 times 6, 2 times 3. Right? And we also talked about this morning, and this will come up in the lesson, we have negative factors of 6. Negative 1 times negative 6. That multiplies to positive 6. We can do the same thing with 2 and 3. Negative 2 and negative 3 multiply to positive 6. And so we went through, I think we got all the way down here to 32. We listed all the factors of 9, 1 and 9, 3 and 3. And we just listed the positive factors. And then 24, 1 and 24, 2 and 12. And then we also talked about, I guess this morning, this is a good thing to bring up, 24. If I'm not sure if 3 goes into it, how can I check that? Well, on your calculator, a way to check to see if a number is a factor, go 24 divided by 3. But what do you get? Okay, on your calculator, you would get 8. 24 divided by 3 is 8. Well, that tells me that 3 and 8 are factors. Okay, so 3 and 8 are factors of 24, right? And then you get to 4. Oh, I'm unsure about 4. Most of us know that 4 times 6 is 24, but if you're not, we'll do 24 divided by 4. Well, what do you get? 6. So yeah, that tells me 4 and 6 are factors together. 4 times 6, 24. And then we got to 32. I'm not sure if we did 32 this morning, but we got to 1 and 32, 2 and 16. If you checked 32 divided by 3, you can see it's not a factor. 4, 4 and 8, 5 no, 6 no. Okay, so those are the factors. All right, so now let's practice factoring some quadratic trinomials. Okay, to do this, I made a note here. You need numbers that multiply to the last term. So we'll be looking for numbers that multiply to the last term. In this case, is 20. So numbers that multiply to 20 and add to the middle term, 9. So some of you, immediately you see the numbers that multiply to 20 and add to 9. And great. If you see the factors of 20 that add to 9, wonderful. If you don't, make a list. Okay, make a list of the factors of 20. Well, I know 1 times 20. Those are factors. But 1 plus 20 is 21. So those don't work. I know 2 times 10 is 20. What's 2 plus 10? That's 12. So those don't work. Is 3 a factor of 20? Check. Well, you'll see that it's not. So 3 doesn't work. What about 4? Is 4 a factor of 20? Yes. 4 times 5 multiplies to 20. Well, 4 plus 5, those add up to 9. So it looks like 4 and 5 are the factors that we need. Okay, they multiply to 20, they add to 9. So now, once I have my factors, I need to write this as again, a binomial times a binomial. I'm undoing my FOILing, so this becomes x plus 4, x plus 5. And my handwriting is close. X plus 4, x plus 5. And the order in which you write these binomials, it does not matter either way. You could also write this x plus 5 times x plus 4. And again, that doesn't matter because multiplication or order doesn't matter. All right. And then so I would let you guys go ahead and look for the factors of 1a here. You'd be looking for numbers that multiply to 24, add to 11. And so you guys could go ahead and do that. Pause, try this one. All right. If you're going back from that pause and trying this one, you probably checked 1 and 24. Well, those add to 25, so not what we're looking for. 2 and 12. Those are factors of 24, but those add 14. Many of you might have then gone to 4, said, oh, well, 4 goes into it. 4 goes into it 6 times. So 4 times 6. Well, 4 plus 6 is 10, so not what I'm looking for. Many of you might have skipped 3. 3 is a factor of 24. It's 3 times 8. So the 3 plus 8 is 11, and that is the factors we're looking for there. Right, and then we wrote this, here are variables d, so d plus 3, d plus 8. Okay, and again, the order doesn't matter there, you could move place around, but that is the factored version of d squared plus 11d plus 24. All right, so example 2, slightly different here. We're looking for numbers that multiply to 12, that's the last one, and add to, well, the add to is a negative. Okay, so we've got to think for a second. What type of numbers multiply to a positive and add to a negative? Well, as we talked earlier, a negative number times a negative number results in a positive. And a negative number plus a negative number results in a negative. So it looks like we're going to have a negative times a negative. All right? So we list the factors, and we know that the factors are both going to have to be negative. Negative 1, negative 12. Well, those add to negative 13, so it's not going to work. Negative 2 and negative 6. Multiply to a positive 12, those add to negative 8. So it turns out that negative 2 and negative 6. Okay. Now when I write my binomial, I'm just going to write x minus 2. X minus 6. Again, the sign there goes now with the factor. Okay, both negative factors, so we use minus signs in our factoring. All right. And we had another example like that where, again, we're looking to multiply to a positive 28, add to a negative 11. So we list our factors. You guys can try this. Pause this. Try this one on your own. All right, if you're coming back, okay, we list the factors. We go negative 1, negative 28. Not going to work. Negative 2, negative 14. That's negative 16. Won't work either. Negative 3 times. Hey, negative 3 doesn't go into 28, so not going to work. Negative 4 goes into negative, or to 28, excuse me. Negative 4 goes into negative 7, which add up to negative 11. So that would be our winning combo there. So I would have had W minus 4, W minus 7. All right. Let's keep moving. Okay, last example again. So here, this is the last type of problem, most complicated, certainly. We're looking to multiply to a negative 15 and add to a positive 2. So here we're multiplying to a negative. So to multiply to a negative, you would need a negative and a positive number. Negative times a positive results in a negative. So we need opposite signs on our factors. But if we want them to add to a positive, we're going to add two numbers here. And we want the result to be positive. The bigger number is going to have to be the positive. So keep that in mind when we list our factors here. So negative 15. 1 and 15 are factors of 15. Like we just said, if they're going to add to a positive number, the bigger number is going to have to be positive. Negative 1 plus 15, that adds to a positive 14. Not quite what we're looking for. 2 go into 15? Nope, it's not an even number. What about 3? Certainly 3 goes into it 5 times. Alright, so again, the smaller of the numbers will need to be negative because we want these to add to a positive number. Negative 3 plus 5 does add to positive 2. So these ones are a little trickier where the signs have got to be opposite. So we go x minus 3, x plus 5. Again, the order in which I write these binomials does not matter. I could also have x plus 5, x minus 3. Okay. And the next problem, still slightly different, but they're still multiplying to a negative. But this time we want to add to negative 7. So multiply to the negative 18. Add to the negative 7. All right. So here, again, they're going to have opposite signs because they've got to multiply to this negative 18. But the bigger number needs to be negative because they want to add up to a negative. So we would go like 1 and negative 8. All those add to negative 17. Not good there. But we notice the bigger negative number results in a negative addition problem. So, well, what about 2? 2 goes into 18 9 times. So 2 times negative 9 is 4. 2 plus negative 9 is negative 7. So that's our combo there. We factor that. X, again, plus 2 or minus 9. Doesn't matter which one I write first. I usually write them in the order I find them. So there we go. 2 and negative 9. All right. Last 2 problems there on the back are for you guys. Okay. Try both of those. That'll count for you guys today for your homework. So here on 3A, you'd be looking for numbers that multiply to negative 48 and add to 13. So if you're able to get that done, that would be great. If not, at least list the factors here of negative 48. List all the factors of negative 48 if you're not able to complete it. And then the next one, you're looking for numbers that multiply to negative 24, add to negative 2. So again, try and complete this one. Very least, you should be able to list all factors of negative 24. All right. Thanks for watching, and I'll see you guys in the morning. Have a good one.